have Cubit here. As Matt mentioned and other videos have demonstrated, Coreform Cubit has an excellent import capability that lets you pull any geometry from other CAD tools. And I want to call out too that, this is a pretty heavy assembly. It's got dozens of parts. There are some repeat parts in here, and opening this up in SolidWorks and NX can take a fair bit of time. And so even just getting to the relevant parts in Cubit is beneficial. Then again, if I'm trying to get to the heaters, it's easy to do, Control Shift Select and just clear out the materials that you don't need. We can start to see that the heaters are here underneath, and again, very lightweight. And here we can see there's some parts, there's some repeat parts here, and hitting the select similar volumes makes it easier to select these parts and then get rid of them also. And so we can see in 30 seconds, if I had no further knowledge about what the heaters are, what's in this thing, being able to use this tool will let me get there in under a minute. So for the sake of this demonstration, I want to go a little bit deeper and again, use similarity selection to select these bolts, these other clamps, and get rid of that, clear that away. And now I'm down to the heaters and these contacts. And I want to share a little bit, some tips about web cutting geometry like this. So this doesn't look that complicated, but what I've found is that web cutting, what you're trying to get out of this is you're trying to make it easy for Coreform Cubit's mesher to understand the cleanest way to produce a mesh. And what I have found is that there are two goals that I pursue. One is to try and get to hex meshing everything as much as possible. Hex meshes are nice because the matrix is a little bit stiffer, the solutions are a little bit more stable. They conform to geometry a little bit better, and it's fewer nodes. It's computationally easier because you have so many fewer nodes and connections for each of those versus like TET meshes. So with something like this, there are some corners here. There's some complex curvatures here. So I'm going to go ahead and work through this a little bit. So in this case, I'm going to say, well, I care about the corners. You could decompose this and just turn this into a smooth surface. But in my case, that's not the case. That's not what I need. So I'm going to start using these features to start cutting away and actually split this apart into multiple different bodies. In here, when I'm picking how to do this decomposition, what I would like to do is use as much of the features of the geometry itself to define where the cuts are going to be, because that enables me later when I check the journaling file to have a consistent solution if the geometry changes. Like very much with these types of things, the team is testing out different parts and different types of solutions. So I can't very often rely on specific coordinates to work on. So as I do this, you can see in the history, this is keeping track of like specific vertices, specific locations, specific planes. And that's going to become handy later when I script this. So as you can see, I'm also cutting away at some of these wings here so that I can create rectangular pieces. And those have been a bit easier to mesh for me. And then here too, in this corner, this discontinuity, I'm going to want nodes at these specific positions too. So again, I'm going to make one more cut right here just so that the meshes between these volumes line up. And then again, from the tutorial, from other tutorials online, one of the lessons you learn is that you should mesh from the most constrained volume out. So I'm gonna isolate this one to be able to work on it. And one of the things I want to show here is now we've got to deal with this complex surface. So you can see these different surfaces here. It's it would be a many-to-many mesh, which would be pretty difficult to do. But by using the composite feature, which I've shortcutted here, I can now look at this volume, control click to select them all, and there we go. Now this virtual geometry has been created, which lets Coreform Cubit know that this should be treated as one surface. And then in the mesh definition, I can focus on the resolution of that surface. So now I've changed this many-to-many surface sweep problem to a one-to-one. So now we can go here into the mesh. If I'm, again, a lot of my teams are not worried in the early phases about specific solutions to things. They're worried about a general idea of where things are to concentrate on. So if I'm doing that, I can assign this a map surface mesh. And then for sizing, in this specific case, automatic sizing actually works out okay for me, because again, they just need a general case of it. And this comes with your own experience with the tool where this is. But of course, Coreform Cubit has many of the other features as well. So I'm going to do this surface up here, and then I'm going to make sure to apply the same properties down here and mesh these two. And then from your multiphysics, from your modeler, so in this case, Moose, there's documentation on how many layers of nodes should be between top and bottom layer to get good solutions. So I believe the solution in Moose is at least 5. So I'm going to mesh these as a curve. So I've got these two surfaces, I've got this target, and now I can mesh this volume. So I've given Cubit enough information to be able to sweep through this properly. And it's pretty good at the auto direction. I'm going to give it a little hint by saying sweep in -y. It's a pretty close axis. And there you go. In just a few minutes, I've created this mesh just for this object, this volume. There are plenty of tutorials about how you take these volumes and combine them together into single bodies, which is how you'll be able to work with them within Moose.